Here I've got a confusion matrix, and this confusion matrix has 10,000 records in it, and it represents scenario number 1, which we'll be looking at. As you can see, this model has made 150 type 1 errors and 50 type 2 errors, but overall is predicted quite a lot correctly. Now let's calculate the accuracy rate in this scenario. The accuracy rate is the total correct divided by the overall total, and it's 9,800 divided by 10,000, which is 98%. Okay, great. But what we're going to do now is we're going to tell the model to stop making predictions whatsoever. We're just going to abandon the model completely, and we're going to say that from now on, our prediction is always 0. We're always going to predict that the event is not going to occur. So basically what will happen to the confusion matrix is these records will move from the right column to the left column, and our new confusion matrix will look like this: 9,850, 150, and then nothing in the predicted column where we predicted that something will occur. And of course, that moves against all logic, right? Why would you abandon a model? But let's calculate the accuracy rate in this scenario. Scenario 2, accuracy rate has the same formula. In this case, accuracy rate is 9,850 divided by 10,000. So it's 98.5%. The accuracy rate went up by 0.5%. And as you can see, what we did is we just completely stopped using a model, but the accuracy rate went up. And that is why you should not base your judgment just on accuracy rate, because things like this can happen. And even though obviously you're not using a model anymore, which means that you're not applying any kind of logic into your decision-making process, your accuracy rate is going up. So it's misleading you into a wrong conclusion that you should stop using models. And this effect is called the accuracy paradox. And starting from the next tutorial, I will show you a much better way to assess your models using the cumulative accuracy profile. I look forward to seeing you then. Until next time, happy analyzing.